Okay, in this video, we're going to learn the skill of computing the present value of future cash flows. So let's imagine that we want to invest $100 in, suppose, a bank account, and we earn 10% interest on the money that we deposit in this bank account. How much will we have at the end of a year? Well, if you thought about it a little bit, hopefully your intuition tells you we'll probably have $110. We're going to earn 10% on that $100. So 10% of the $100 is $10. That adds on to our existing $100, and we have 110 at the end. And here's the formula that you use to compute that. So I'll put 110 at the end here. You use this future value formula to compute your answer. You took the present value, so today's value is $100. You multiplied it by 1 plus the interest rate. The interest rate was 10%. And you raised the quantity of 1 plus the interest rate to the power of n, where n is the number of periods. In this case, n equals 1, okay? So the interest rate was 10%, number of periods is 1, and the present value was 100. Now, in accounting, what we're going to mostly do is we're going to reverse this formula. So rather than caring about what is the future value in my bank account, assuming a 10% interest rate, I'll wonder, well, if I receive $110 1 year from now, what is that worth today? What should I invest today if I want $110 a year from now? And for that, we're going to use this here, present value formula. And it's the same formula, just using algebra to solve for the present value part of that formula. So what you do to do it is you take the future value. The future value is what it is when the cash flow occurs. Okay, so we want the cash flow a year from now to be 110. And we divide that by the quantity of 1 plus the interest rate, which is 10%, raised to the power of n, where n is the number of periods. Okay, so now let's look at two examples. Let's do these questions. What is the present value of $100 now? So we did 110 before, but now we just want $100 1 year from now at a 10% discount rate. So that $100 is the future value, 1 year is n, and 10% is the interest rate. So we calculate that in this way. The present value is 100, future value, divided by 1 plus the interest rate. The interest rate is 10%, which converts into 0.10, okay? So percentages stated this way, it's percent means per 100. That's what cent means, is 100. So per 100, it's 10. 10 out of 100. And so 10 over 100 is 0.1, okay? So 1 plus the interest rate raised to the power of 1, since it's just 1 year, okay? And so what we would say is the present value of $100 a year from now at a 10% interest rate is $91. That's what I should invest today in a 10% earning account if I want $100 at the end of 1 year, okay? Now, one more thing we can do is we can apply this to multiple future years of cash flows, okay? What is the present value of $100 each year for the next 2 years using a 10% discount rate? And this is something we'll see pretty frequently when we talk about bonds and leases, is that a bond contract entitles the bondholder to multiple years of receiving cash flows. And when you get into a lease, you're required to make payments to whoever holds the lease. You're required to make payments to them every year. And so we need to compute the present value of a stream of cash flows. In this case, the stream is pretty short. It's two $100 payments, one that's a year from now and one that's 2 years from now. We'll use a 10% discount rate. And so to do this, we're just going to add these two terms together. $100 1 year from now, divided by 1 plus the interest rate raised to the power of 1, because it's 1 year away, plus $100 2 years from now, over 1 plus the interest rate raised to the power of 2, since it's 2 years away. And that total is 174, okay? Now, the 1 year away payment, the present value of it is $91. The 2 years away payment, even though it's the same amount, the present value of it is lower. It's only $83. And hopefully that makes intuitive sense for you, because you would probably, if I gave you the choice, I'll either give you $100 1 year from now, or I'll give you $100 2 years from now, you probably have the intuition that tells you you'd rather have $100 1 year from now than 2 years from now. Because you could take it at the end of next year and then invest it in an interest-bearing account and have even more money 2 years from now, right? And so sooner payment is more valuable to you if you're receiving cash. Now, if a company is having to make a payment in the future, they would rather push those payments off, right, to make them less painful. And so a payment that is going to be outgoing payment is more painful if it's closer and less painful if it's farther away, as you can see here. So in conclusion, we use this present value formula to compute the present value of future cash flows. You take the future cash flow amount in the numerator, you divide it by 1 plus the interest rate that you're using to discount that cash flow, and you raise it to the power of n. You raise the denominator to the power of n, where n is the number of periods, and typically that'll be the number of years that the cash flow is away. Now, when I say periods here, the key thing you need to know is that it needs to correspond with this interest rate. So if this interest rate is an annual interest rate, which is how we normally state interest rates, how much does it earn you per year, then n needs to correspond to the number of years. So if this is an annual interest rate, then this needs to be the number of years. Do you see how interest rate needs to correspond with n in this formula? So the present value is the future value divided by 1 plus the interest rate raised to the power of n.